in section 4.2, we're still looking at graphs of rational functions, but we're going to put everything together. Okay. Before we do so, let's review some parent graphs that we should know. Okay. So y equals x squared, we all know would be parabola opening up with a vertex at 0, 0. Y equals the absolute value of x, our v shape, right, versus our parabola was u-shaped. Square root of x, we know is arc shaped. It has to have a starting point. It would be 0, 0, going off and up and to the right. And y equals x cubed, again, going through 0, 0, has that S shape that we call it. Okay. Now, let's also review that parent graph of y equals 1 over x. So remember, there's an asymptote at x equals 0, and it's in quadrants 1 and 3, looks like that, and you should be extending the end behavior to show the horizontal asymptote at y equals 0. Now, if we're going to be using that as your parent graph to understand y equals negative 1 over x, well, you know a negative reflects it across the x-axis, and therefore it's going to look the same in general, but be drawn in quadrants 2 and 4. Okay, of course, you've still got to get that full thing drawn, x equals 0, and you've got to extend the left side. I'll just let that label work for that one and say y equals 0. Okay, now think about what 1 over x squared is going to do. Back from the parent graph of 1 over x, we saw this one before. All the y values, since you're squaring the x, are going to be positive. So this over here in this third quadrant is now going to be reflected across the x-axis and end up in the second quadrant, if you will. Okay, so once again, x still can't be 0, so you still have an asymptote at x equals 0. And again, you still have to extend the left and the right, and horizontal asymptote at y equals 0. But now it's going to be drawn in quadrants 1 and 2. Okay, now we have a name for that. You'll sometimes hear your teachers say that looks like kind of a fountain around x equals 0, right? Because both of the arrows are going around or going in the same direction. So you'll sometimes hear us call this like a fountain graph. And the fountain is going around x equals 0 in this case. So then using that knowledge, if I was to ask you to draw 1 over x minus 1 quantity squared, I'm not going to draw it, but you should recognize that that would just be shifted from this one on the left, right beside it. It would be shifted to the right one. So if you described that to me as a fountain graph or a fountain around x equals 1, I would know exactly what you're talking about. Okay. Now, if you did not already do it in the last notes, because I told you that was to get you ahead, then you're going to have to stop the video and go ahead and write these steps down for graphing rational functions. These are exactly the same steps from the previous sections. Okay, so there's 1 through 5, and there is also 5 through 8 again, so get those written down. All right, so our examples, guys. Let's sketch a graph of each rational function. We'll practice 3 of these, and I know sometimes it does not show up very well, but there is a fraction bar right there. Okay, so y equals 2x over x minus 3. We want you to be able to draw this without any use of a calculator. So here's really what I would like you to do. I think it's easiest to make 2 different columns. Okay, so I'm going to teach you right off the bat on this easier one to make 2 columns, because there's 3 things you do from a factored form, and there's 3 things you do from the original equation form. Now in this case, you know number 1 says factor the numerator and denominator. There's nothing that factors, okay? But I'm just going to start dividing them into columns in the first place. So here we go. First things first, always find holes. Holes occur when something cancels. There are no factors that cancel. So if I ask you for holes, there are none. Now, like on the next quiz, guys, I'll just have a blank for each of these things because I'm not going to tip you off which one have a hole and which one don't have a hole. I'll just write holes blank, and I'm expecting you to either tell me there is one or tell me there is none. After holes, you do vertical asymptotes. Okay, vertical asymptotes come from what x can't be, right? The exclusions after you've done holes. So x can't be 3, which means there's an asymptote at x equals 3. And then x-intercepts or roots, as you also know them, roots. Okay, remember, for that, you're setting y equal to 0. So if you set y equal to 0, you're looking at where the fraction equals 0. The only way for a fraction to equal 0 is for the top to equal 0. You'll get x equals 0. And so that ordered pair is 0, 0. That should always be an ordered pair. These come from, again, I know it doesn't make a difference in this specific problem, but these three things are what you should do from the factored form of the original equation. Okay, and then in the next column, you will do, let's do y-intercepts first. So y-intercept, for a y-intercept, remember you're setting x equal to 0. So you would have y equals 2 times 0 is 0 over 0 minus 3 is negative 3, so that's still 0. Okay, so that's the ordered pair 0, 0. Horizontal asymptotes. You'll do next. Horizontal asymptote, highest powered term, it's 2x. Over the highest powered term is x. If you reduce that to be 2, that means I have a horizontal asymptote at y equals 2. Guess I should have boxed this also. So you're looking for all of these things that I can find. And last but not least, slant asymptote. And remember, slant asymptote occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. That doesn't happen here. They're the same. So when I ask for a slant asymptote, you're just going to say none. So again, there's a bunch of blanks that I can ask you in this section just to get a bunch of points from you. I'll go ahead and box this also. So if I'm going to put holes, vertical asymptotes, x-intercepts, y-intercepts, horizontal asymptote, and slant asymptote on every problem, you can see where the points can rack up quickly. Okay, so this column is going to be from the original form. Okay, so before you factored anything, because it will sometimes make a difference. Now, like I said, it doesn't make a difference in this problem at all, but I'll just get you used to those two columns. Okay, all right, from here then, when I go to the picture, why don't you see what you can do and then come back and check. Okay, so I like to start out with any ordered pairs. So I know I'm going to go through 0, 0. I know I have a vertical asymptote at x equals 3. Okay, so get that extended and labeled so we don't forget it. X equals 3. A horizontal asymptote at y equals 2. And I know it's end behavior, so get it off to just the sides out here. There we go. As long as you got it labeled on one side, that's good enough for me. We go through 0, 0. Again, I need a point on all sides of the vertical asymptote. Well, on the left side of the vertical asymptote, I've got this 0, 0. I'm comfortable drawing this right now. If you're not, plot another point. But if I'm going to hug or get very, very close to the asymptotes without crossing, then putting them in my arrows, that's that. I know I have to label the point. Okay, anything that I found has to be labeled on the graph. There's that. Now I need something on the right side of the asymptote. That means just plug in a number that looks like maybe it's easy for you to plug in. So for instance, if I take x equals 5, If I plug in x equals 5 into the original equation, 2 times 5 would be 10, over 5 minus 3 would be 2, so 10 over 2 would be 5. So I'm just plotting points, okay? It sounds like 5, 5 is on my graph. There you go. That's all I need. I know if I'm going to get close to this asymptote without crossing and close to this asymptote without crossing, that I'm going to look like that. Okay, I'm comfortable with that. If you need to plug in 6 and 7 and 10 to convince yourself, then do so. Okay, do label whatever point you plugged in for me so that I know what you did. Okay, there would be the first one for full credit. All right, let's try this one. Again, we always factor first. So taking out the GCF of x, leaving us with x minus 3. And on this one, x plus 3 times x minus 3 are difference of perfect squares, right? So let's start in order. Okay, so first thing I'm looking at, and remember, where am I looking at holes, vertical asymptotes, and x-intercepts? I am looking at the factored form, okay, because I haven't written that yet. So in the factored form, maybe we'll just put it above here for right now, because I might run out of room to put them beside each other anyway. So understand that this is from the factored form. All right, so what would cancel in the factored form? Well, I noticed that those would cancel. And whatever cancels creates a hole. Whatever you cancel, you set equal to 0. Remember, resolve for x. And then plug that into what's left over. Okay, so notice that's why it's in the factored form. If you plug 3 into the original form, you'd have a 0 in the denominator. That would be confusing. All right, so in the factored form, if you plug 3 into what's left that you haven't canceled, you would have 3 over 6, so a half. That means 3, 1/2, that ordered pair is your hole. Okay. Vertical asymptotes then come from what's left that x cannot be after you've done holes. So notice in the factored form, I still have x plus 3 in the denominator. That means x can't be negative 3. So therefore, there's an asymptote at x equals negative 3. And likewise, x-intercepts or roots come from the factored form. Okay, so if once again, a fraction is equaling 0, right? Because this is when y would equal 0. Then it's only the numerator. So what's left in the numerator is x equals 0. So that ordered pair again is 0, 0. Okay, so once again, all of those three were from the factored form. Okay, versus the original form. All right, and maybe I don't want to clutter it to the right. So I can put these, I like the idea, just so you kind of know, I like the idea of putting them next to each other, just because it makes it easier visually for you guys to just always go what's above, okay, it. But I'll leave that up to you. Just be careful not to confuse yourself by having these two stacked on top of each other. So for a y-intercept, remember you're letting x equal 0. And this is in the original form. So in the original form, if you plug in zeros for x, you're going to get 0 over, what, negative 9? So 0, which means you have a y-intercept at 0, 0. Okay. Next, horizontal asymptotes come from highest powered term in the original, the highest powered term over the highest powered term. And both of them happen to be x squared. X squared over x squared reduces to 1, and therefore your horizontal asymptote is at y equals 1. And in slant asymptote, the last thing it's always going to ask you happens when the top and the bottom have a degree difference by 1, but in this case they're the same. So you're going to say none. All right. Again, these three came from the original form. All right, if you want to try graphing it yourself, turn it off and then come back. See what we can do. Okay, so I like to start out with ordered pairs, especially the 3, 1/2. So 3, 1/2, I'm going to just put a nice big hole there. Okay, make sure that you don't draw through it. Make sure it's easy to find. Ordered pair 0, 0, I see is on my graph. Found that a couple of times. And my vertical asymptote is at x equals -3. Let's go ahead and get that taken care of. Sorry, that won't let me do that on the video, but extend it. Okay, above and below. X equals -3, get it labeled. We have a horizontal asymptote at y equals 1. All right, so remember that's only the end behavior. So I'll put y equals 1 here and y equals 1 out there. No slant asymptote, and I think we're set and ready to go. So again, that hole is kind of like an ordered pair to me. It's undefined, it's open, but that's a point. So is the 0, 0, right? Because I need to have enough points on each side of the vertical asymptote to be comfortable what this looks like. Well, I'm comfortable. I know it's coming from the right side of the hole and getting close to this and not crossing. Likewise, it's coming here and getting very, very close to that asymptote. Yes, I have to label the 0, 0 point that we found in the problem. I need to label the hole is 3, 1/2. Okay, for me to grade. And now I just need to do the left-hand side. Okay, on the left-hand side, plug in something that seems easy for you to plug in. Okay, I plugged in 1, 2, 3, 4, 5. And again, you can do this in the factored form, like what's left over. Okay, so I plugged in -5 and you would get -5 halves, sorry, +5 halves. So -5 and 2.5. All right, so there's a point. Again, that's enough for me. I know I'm going to get close to this asymptote and likewise close to this asymptote without crossing. Label the point that you plugged in, so -5 and 2.5 or 5 halves. Okay, if it's not a nice decimal that ends. And there you go. That would be a full credit answer. Okay, let's try one more. Okay, if you want to try everything yourself, go ahead and turn off the video. And then check back. All right, factoring everywhere. The top, x plus 2, x minus 2, difference of perfect squares. And the denominator, x plus 1. So here we go. In the factored form. I'm going to find holes always first. And I noticed that there are no factors that cancel. So my answer is going to be none. Vertical asymptotes next. What can x not be? X can't be -1, so your vertical asymptote is x equals -1 from that denominator in the factored form. Your x-intercepts or your roots. Remember, you're setting y equal to 0. So the only way for a fraction to equal 0 is for the numerator to equal 0. Can't divide by 0. So you're looking for where that equals 0. And that's going to happen at plus or minus 2. Therefore, the ordered pairs that we expect for the roots are -2, 0 and +2, 0. Okay, please write them separately. And then we will go to, so all of that is your factored form. And then we will go to your original form. All right, and continue by finding the y-intercept, which occurs when the x values are 0. So in the original form, if I plug in 0 for x, I'll have negative y equals -4 on the top over 1 on the bottom. So -4. That makes my y-intercept 0, -4. Always make those ordered pairs. My horizontal asymptote after that. From the original, the highest powered term is x squared over the highest powered term is x. That reduces to x. You're always asking yourself the same thing. As x gets large, what's happening to the whole thing? Well, as x gets larger and larger and larger, y gets larger and larger and larger. I don't know how to draw an asymptote at y equals large. So that's your tip off that it should be none, and that more than likely something else is going on, like possibly a slant, also known as oblique. You need to know both words. Asymptotes. Now remember, slant happens when the numerator has a degree higher than the denominator by 1. Exactly what's happening here. Okay, so it says do long division. Okay, perfect. That's a good review for us. We're doing x plus 1 into placeholder for every power. So x squared plus 0, x plus 4. Nope, minus 4. Okay. So go ahead and do that quickly and then check. So x and x squared is x times each of those, lining them up under their appropriate power. Draw the line, change your signs. I always go with the top sign. So this will add straight down, get negative x, bring down the next term of -4. X into negative x is -1. So you can go ahead and finish this. Distribute to get the negative x and the -1. Draw your line, change both signs, add straight down, and have -3. But what you need to know is that in this process for slant asymptotes only, you always ignore your remainder. Okay. And whatever you get as your answer up here, you just simply put a y in front of, and that actually is the equation, it has to be an equation, of your slant asymptote. Okay, so y equals x minus 1. Sorry, I keep writing plus. Okay, y equals x minus 1. Box it. Now, why does it have to be? Think about, why do we say for a slant asymptote, based on the answer you just got, why does the degree have to be exactly one more than the other? And hopefully you're thinking, oh, because slant asymptotes are still lines. It has to be linear. Okay, that's why it has to be one more. I will just give you a big caution and say be super cautious if you don't use our recommendation, and be cautious if you're using synthetic division for slant asymptotes, because if you forget not to reduce the things that you need to reduce when we talked about synthetic division, you could get yourself in trouble real quickly there. So I highly recommend you use long division. Okay. All right, so there's that caution statement. And then back again one more time. Remember, these three come from the original form. Okay. If you want to try to put everything together now and do your graph yourself, go for it, and then come back. Now for me, when I start graphing and I have a slant asymptote, that's probably what I'm going to draw first. So make sure that you just draw that y equals x minus 1 line the best you can. Okay. Yes, we definitely want to label it. We'll come back and do that. Okay, after we're sure where we won't be doing that in the way. And then we have -2, 0 on the graph, +2, 0 on the graph, which I guess is right there. What else did we have? A y-intercept of 0, -4. So we're going through that point also. And vertical asymptote at x equals -1. All right, so let's get that guy in there. Extend, label it. X equals -1. And now I think I have everything in there, and then we'll just label. I think I have everything I need. Remember, all I need is 1 point on each side of the vertical asymptote. Notice this time I have that, okay? So I know on the left side that this is going to get very, very close to this asymptote this time and not cross, and very, very close to this asymptote and not cross, okay? So if I just add the -2, 0 ordered pair for that point, I'm set on that side. On the right side, I've got 2 ordered pairs to get through. Okay, so do the best you can getting through both of those and making it get close to the asymptote without crossing. And same thing here. It is following that asymptote. Okay, and then we just need to label your 0, -4 and your 2, 0. You've got the arrows on there because they go on forever. And now I can label the slant asymptote as y equals x minus 1. Okay, and you have everything that you need to get full credit for that one. All right, do a good job practicing this, guys. It's an important concept that'll keep coming up for graphing and rational functions. All right, do well.